Alright, how's it going, everyone who has picked this live stream up after the fact? So welcome to the now VOD or video of this live stream. My intention in this stream is to go through a couple of bits I've got here. I've got a QSC amplifier with a switch mode power supply fault, which I've diagnosed already, sort of a bit, and it looks very interesting. So I thought I would leave it for a stream because I think that might be really interesting to go over. Also want to be looking at a Taramps MD12K, going through how that circuit works in a similar way that I have done with the Big Boss 8 from Taramps, just kind of showing you the differences between the MD series and the Big Boss series and Smart series, etc. And I've also got some more parts arrived for the Camco amplifiers, which I have been repairing, and we think we have figured out most of the problems with them. So, and if we get all done with that, I've got plenty more things we can crack on with. So this is going to be a nice little chilled Tuesday night live stream while I'm in the workshop cracking on with some repairs. How's it going, everyone? What's up, Pradeep and Lee? What's up? How's it going? Hope you guys are doing well. Let's just get this cooking. Move that over there. Move that down there. So yeah, and just while the stream picks up a little bit of pace, I'm just going to be taking a real quick look. This is a prototype amplifier from a Chinese build house. Lots and lots of different brands use this board layout, but this is an old prototype that some guy is actually using in his install, and I think it's got a shorted transformer wind. So we're just going to see if we can identify that and resolve that for him. How's it going, Blisterio? How's it going, Damin? What's up, bro? How's your amps doing? What amp are you using mostly nowadays? Did you put up your 16K for sale, or using that? I can't remember. Chris, how's it going, my man? I'm glad that you are attending the live stream as well, my man. Glad you're here as well, bro. Can't lie. So with this one, the reason I think it's a shorted transformer wind is, firstly, I mean, the transformers are like literally just hanging in there, wobbling around, super low FS. That is pretty horrendous. Secondly, we have just 8 FETs blown on this transformer here. Now usually when a power supply goes down, it takes out the whole lot, unless it is a failed transformer, in which case it's often just the FETs on the transformer that failed that go down, and that's what we have here. These ones are all absolutely fine. I've got some almost identical batch 064Ns here, so we can drop those in without having to worry about batch tolerance differences causing these new ones to do more work or less work than the original ones, because they're of a very similar batch, so the tolerance differences will be negligible. So just dropping these in, and I'm going to see if we can identify whereabouts on the transformer the short is, because without even powering up, I can almost guarantee you this is a transformer short. Yeah, this is probably like a kind of circuit layout prototype. It was never intended to really be installed and used in a vehicle, so therefore there's been absolutely no care and attention given to the seating down all the transformers and all that stuff, because it was probably just to showcase how the circuit is functioning and the kind of power that it makes, rather than building something to be reliable and work for a long time actually in the install. The Smart 5 base is going good, and the 16K is under the bed. It's still up for sale. Okay, so you have put it up for sale, yeah. Or I'll use it when I have the power to make more power. Yeah, good idea. Good idea. It's always nice to wait until you've got some power before you can make power. Taramps M1 clip thingy. Crap, and the pads fell off. Taramps M1 clip thingy. What's the M1 clip thingy? Is that the base remote, do you mean? The pads fell off. So I just wired 3 LEDs, 2 blue, 1 red, common grounds, and red, yellow, green to anode seems to work. Any thoughts? I'm not sure what you're referring to by the M1 clip thingy. I'll have to have a look at that. The monitor remote, is that? What do you mean by the pads fell off? How's it going, Matthew? Yo, mod's in the chat. Mod, how's it going, bro? It looks like a very cool amp you've got on the bench. It's not, but yeah. Amir, yeah, you're a little bit late. Amir, usually you're like right up on there straight away. Badass says my sound is, so basically sounds like we've got a, this is going to be the case for the, so now it should be synced back up. I haven't got round to diagnosing or sorting out the issue with my USBs being overloaded. I haven't got around to that yet, so I'll just have to keep resetting it every time, but that's fine. We can roll with that. Just keep me updated. Just whenever you hear a delay, just be like, yo, delay, and I will just reset. That's cool. We can do that. So just tacking these gates in so that I can turn this board upside down without all of the FETs falling out. There's one here that I haven't quite done a good enough job of getting rid of the solder in the via here. So let's just do that, get that up to the same height as the rest of them and bend it over. Nice. In inductors, like the bigger ones on this board, are different coloured windings meaningful? In this case, it will just be to differentiate between primary and secondary. So I guess it just makes it easier for when they're looking at the transformer to make sure it's been wound correctly, make sure the spacing is correct, to have the winds be different colours, just so that you can identify, oh yeah, the primary is all over here, the secondary is spaced out evenly. And if they see one where it's all over one side, or it's not very well wound or whatever, they can easily identify where the issue is. How's it going, Robert? How's it going, my man? Hope you're good. I don't know about you guys where you are in the world, but summer has not hit yet. It's the middle of June. And it's 12 degrees Celsius, bro. What is that about? It's pretty sad. I'm a hot weather guy. I do like myself a bit of hot weather. You know, some people complain about if it gets to like 30, 32, 35 degrees Celsius. A lot of people will be like, oh no, it's too hot, it's too hot. Can't do it. I absolutely love it. I love the big hot weather, man. I feel like I can get loads done. I feel happy being outside working on the car, just existing outside. I don't really like being cold at all. I kind of freeze up and I can't do anything, even when it's not that cold. Lowry, yes, you are late, buddy. You're usually number one. Have you had any more shocking experiences? Nah, man. Nah, it's a rare occurrence. I'm usually pretty good. I think it just caught me off guard with the how the PA amps work slightly differently in terms of their power switch kind of thing. I was expecting, especially, it wasn't even that. It was like, I know that most PA amps, they have the power switch is just literally a break in the mains wire, right? But it was the way that this certain board was laid out. It straight up looked like it was some kind of enable pin on the 3525. So I was like, yeah, it's fine. And forgot that I had one of my other hands on a grounded extension lead, so. What's up, Henrik? I'm from Sweden. It feels like we already had summer 3 weeks ago. Now it's cold as. Yeah, similar thing actually we got here in the UK. We had a couple of weeks ago, we had some scorching weather, really nice hot days, really good. I was like, yes, it's arrived. But now is gone again. Matthew says, I got the chance to play my system loud today with people out. The bass is so much louder with the desk moved the slightest bit to the right. That's how bass works in a room, especially. Well, yeah, in a smaller space, you will get very, very intense peaks and valleys in the response of your bass just due to reflections, creating standing waves which have points of constructive overlap and destructive overlap. So you'll get these very extreme and often not that widely spaced out areas in the room where just moving slightly one way or the other causes either a lot more or a lot less output. And it's really annoying. That's why you have people like sound deadening, bass traps, etc. to prevent the reflection from causing a wave back in the room that then destructs the original one. How's it going, Florida man? Good to see you, buddy. I have a Scar SKB 3500 and sometimes hear a whine or noise in the sub. In the sub. Best way to test this outside the vehicle to see if it's not just crosstalk. If it's in the sub, that's interesting. That's not a particularly good sign. Sometimes you'll get a whine from the actual amplifier circuit board itself, and that's fine. It's not ideal, but it's not a problem as such. It just suggests that the transformer whines might be a little bit loose, but it doesn't affect the performance or anything. And they're just kind of like oscillating backwards and forwards a little bit. But if it's coming through your sub, that suggests either, if it's coming and going, I wonder whether there's a short on the output inductor, but not enough that it's causing any actual problems with the output stage. It's just reducing the effectiveness of the output inductor briefly. Pull it off, pull it out of the car, put it on the bench, and see if you can replicate it through a small speaker or subwoofer connected on the bench with a low current power supply. And while you're doing that, give the amp a whack. Move it around a little bit, try and simulate a bit of road vibration to see if you can get it to happen. What setup is in your own car, especially the front stage? I don't have my end game setup. Like if I was to spec up a system now, front stage or whatever, I'll do it differently to how I've got it. But at the moment, I have in the Proton, which is my daily car, I have a three-way active setup. It consists of Digital Designs' old style A series, so the older A series three ways. So the AT28 tweeters, AW3s. The tweeters and the threes are on the A pillars, and they're facing angled really, really nicely. And then the AW6.5 is in the doors, and the door is a 53 hertz transmission line. So I have a transmission line, or two transmission lines, one on each door, that the AW6.5s are in, three-way active, and it's all time aligned and crossed over and EQ'd, etc. just by an Alpine 9855R. So I do plan to get a DSP in there, but because the positioning is so good, you don't need much correction. That is where a DSP would really come into its own, offering you massive amounts of flexibility when it comes to corrective adjustments and things like that. Because I have the speakers positioned so perfectly and the Proton cabin is quite dead anyway, I don't really have a lot of corrections to do. So the time alignment per channel of the 6 channels and the decent crossover settings and EQs on the 9855R are adequate for me to get like very, very, very close to perfection with that setup. The amplifiers that's running that is a Genesis special edition 8 channel from 1999. It's a very high bias class ABs, on the tweeters and the 3.5s, and on the 6.5s I have again, because it's an A channel, there's a couple of dual mono boards in that heatsink as well, and the dual monos are bridged, and each 6.5 is on a bridged amp. Basically it has a whole dual mono to itself, which is like massive amounts of headroom, so it sounds really freaking dynamic. Florida man, I had another dead TL494. This is super rare, bro. For me, anyway. Maybe it's got something to do with different climates. So in the UK, obviously, it doesn't really get super hot or super humid or whatever. It's just kind of averaging on dull. But in hotter climates, more humid climates, where there's higher swings in temperature, colder winters, hotter summers, maybe the 494s suffer a little bit from that, because yeah, barely ever see that here. I can count the number of dead TL494s I've ever had on my hands in like 10 years of repairing amps every freaking day. So it's super rare. Through hole and old. Very strange that it died. Yeah, absolutely, super strange. Have you ever had any almost caused a fire situations? Yes, but not with the soldering iron. I had an almost caught a fire situation a while ago with the heat gun. Absolute freaking idiot. I had music blaring, which isn't really something you think is like a problem. I had the music blaring in the workshop, pumping some tunes, doing some repair work, and the heat gun had slipped from where I keep it. I keep it in like a kind of holder to the side here. It slipped a bit from where I keep it, and in doing so, the slip had turned on the switch, and it sort of it had fallen onto the carpet basically, but it was fine because it wasn't on, because I keep the main plug switched off at the top here. The main plug for the heat gun is also shared by my printer and the big 200-watt Weller soldering iron. I needed to use the soldering iron, the big one, so I flicked on the switch, and obviously because the heat gun was now on the switch on its unit itself and on the carpet, that's now come on. Haven't heard it because of the music, so I've just turned it on, carried on with what I'm doing, and like probably about 20 seconds later I'm smelling, I'm like, oh, something smells bad, what's going on? I look down, and there's like a nice big burn hole in my carpet from the heat gun. So that was interesting. But apart from that, no, haven't had any. That was the only time where any mistake that I've ever made could potentially have been bad in terms of causing a fire. But in 10 years, that's not too bad, considering how unprepared and unprofessional a lot of my setups have been over the years. Evening. Hello, Yalon. How's it going, buddy? Okay, so I'm just going to quickly. This isn't the amp that I'm intending to work on tonight for you guys, anyway. But I'm just going to very quickly see whether what's going on with the shorted transformer here, because I'm a little bit curious, just while the stream kind of picks up a little bit. I don't think my clips are going to fit in this one. Maybe they do, just about. The ground one fits, just about. So this amplifier that's on the bench right here, it's deceiving. It looks like a beast, but it's just a really old-fashioned circuit, so it looks big, but actually this is a piece of crap. This massive board only benches about 2K, which I know some people are going to come onto the stream where they're a bit older and they come from a PA or hi-fi or whatever background, and 2000 watts sounds like a lot of power. For car audio application, it's really not, and this is massive. For 2K, there's no need for it these days, modern MOSFET tech and all that. So if I turn the scope on and turn the power supply on, what I'm expecting to see is the drain waveform shape on these bank of FETs. I'm expecting it to look kind of bad, and one or two reasons. Firstly, it could look bad because the drive circuit got damaged when the FETs blew. I haven't changed the drive circuit because it looked fine, but it probably is damaged. So we're probably going to see some bad looking waveforms from the drive circuit, in which case we'll replace those. But I'm a bit more interested to see what kind of waveforms we get because of the shorted transformer, which I'm sure that we have. So let's power her up. Make sure that there's nothing under here. Okay. Going to keep the voltage super nice and low at about 9.7 volts there. I'm going to allow about 3 amps in at the moment. Calibrate that. Okay, so let's power up and let's have a quick look at this drain waveform on the scope. Let's get the camera a little bit away. There we go. Okay. And reject low frequency. Okay. Okay, so it looks okay at the moment on that side and on that side. However, I suspect that the transformer is bad. So if I just grab the transformer like so and just kind of wiggle it into a slightly new position, we can see whether we get any sparks or arcing. Interestingly, we're not. It's very, very wobbly, so I really suspect we should get something funky going on here. Ah, yo, Damin, for the 350. Thank you very much, dude. That's very kind of you. Appreciate that. Interesting. Not getting anything as of yet. Okay. Ah, there it is. There it is. It was a lift up. So if I grab the transformer and pull up, there it is. You see that? It disappears. Waveform disappears. High current draw. Okay. So that's going to be, if I turn that off and have a quick look with the eyes, that's probably going to be this wind here. So it's when we pull up on the transformer. So it's going to be either this wind here, or actually that's the only one it can be. Ah, this one here. Actually, this looks a little bit discoloured here, so it's probably that one. Yeah, you can see there's actually been a bit of rubbing. The red coating is disappeared from there. So if I take the multimeter and do a continuity test between 12 volts, is that, I wonder if that's is that output side or is that primary or secondary? I shouldn't be able to read any continuity to this here. Yeah, there we go. So obviously that means that the lacquer's gone. So that's where the short is on the transformer. So we'll need to, what I'll probably do is, this will be really easy enough to just desolder this, let this wind, pull that back, isolate that with some tester tape, electrical tape, heat shrink, something like that, pop it back over, and then this needs some adhesive, some silicone sealant, some mastic, something like that to prevent it from vibrating, to stop any more of those shorts. Alright, let's get this piece of junk off the bench, start looking at something more interesting, shall we? Okay. Delay should be gone now. We're going to have to keep doing that this evening, unfortunately. Unless there's a setting I can change somewhere that will fix it. If it's an over. Basically, I'm saturating my USB bandwidth, and so that's kind of why that happens. So I'm wondering if there's any of the settings I can change on any of my cameras or anything like that to free up some bandwidth. So that it doesn't keep delaying. But yeah, I'm already running the webcam at the lowest possible resolution, 720p, 30 fps. So I don't think there's much else I can do. I just have to keep resetting it every now and then. When the delay happens, your mic cuts out for a few seconds. Yes, so that is literally just going to be the USB bandwidth being exceeded. So it drops one of the devices. It just happens to be the mic in the webcam probably just gets dropped, because that's probably the last one that was connected. This webcam is the last one that gets connected. So I wonder actually, if I reset, if I just go to here, if I reset, deactivate and reactivate one of the other cameras, for example the hat cam, yeah, let's deactivate and hang on a minute, if I sandbag the hat cam down to 720, that might free up a bit of bandwidth. So now I've done that, I wonder, unfortunately the resolution is now less, but I don't know if that would look much different on your end or not anyway, I don't know, but I wonder whether sandbagging that down to 720 will free up enough bandwidth for the microphone to not do that. Can you not use the StreamCam mic instead like before? I don't think the StreamCam mic sounded very good. You guys will have to let me know. But I can try the StreamCam mic instead. Let's have a look. If I go to Hat Cam, go to Hat, and then scroll down to it's the, what is it? StreamCam, Logitech, Game Capture, Logitech StreamCam. Here we go. Side cannon, Hat. Okay. Right, so now you're listening to the audio from the Logitech StreamCam mic. It seems a bit peaky. So obviously the microphone only works on scenes in OBS that I have this camera active on. But let me know if that's any good or not. It says it's loud. But yeah, what does the audio quality sound like on this one compared to the Osmo? So this is the Hat Cam mic. If I mute this one, and this is the microphone on the Osmo, the DJI Osmo. I know it's going to be quieter. But is the quality better on the DJI Osmo? Yeah, I think that there's no natural background sounds, is there, from... If I just use this webcam, there's no sounds of the scope or anything like that. What I'm going to do is leave it on this microphone for now, and we're going to see if the delay comes back. If the microphone delay returns, then I know that changing my Hat Cam from 1080 to 720 didn't affect anything, and I can just change mics. Osmo's better. Okay. Right, anyway, what am I going to be looking at now? I think we should look at this QSC. It's really interesting. Covered in thermal paste as usual. Okay. Focus. Focus on hand, focus on the amp. There we go. So this is a QSC Powerlight 2 PL236, and this has come into the shop with the fault that there is absolutely no power at all, no life whatsoever from the amplifier. So I've been looking at this over the last day. Like yesterday I was looking at this for a bit and going through a few bits, and thought it'd be interesting to continue on stream because I just thought it was an interesting kind of fault. It's not your normal kind of blown IGBTs or blown output transistors. There's something wrong with the circuit that controls the SMP in this thing. So I thought this would be really interesting to have a look at. What's the difference between high voltage and low microfarad and low voltage high microfarad capacitors on the output side? It's not like a difference really. For capacitors on the output side, you want basically as high microfarad rating as possible while being enough voltage for your rail. So if your amplifier has a 200 volt rail, then you need at minimum 200 volt. Sorry, if your amplifier has 200 volt rails, you need 250 volt caps at a bare minimum, and then basically what capacitors can you afford and fit for your design that have as high microfarad rating as fits in your design and as fits in your budget. It's not just about the microfarad rating. There's lots of other specs of capacitors as well that make them good candidates for rectification filtering from a power supply and used for rail buffering. It's not just about the microfarad rating, but yeah, there's not really a trade-off in that way. You just pick one that's the voltage you need, and then the rest of the specs. Has one big cap been replaced? No. So basically what's happened here is the capacitors have heat shrink on them, obviously from factory. This one right here is very close to this heat sink, which has obviously just got hot, and the constant close proximity to something hot has caused that heat shrink to shrink even further. So it's pulled back and shrunk even more than all of the others. So that's why this capacitor looks a bit different. Yo, how's it going, Simo02? Another mod in the chat. How's it going, bro? So let's get this thing with a plug and start diagnosing. We do have, fortunately, for the first time in a while, we do actually have a service manual for this, which is really cool. So let's pull up the service manual and we're going to show you guys how this works first before going any further. And I think, do I have the service manual downloaded to the PC? I hope so. Yeah, hang on a minute, here we go. QSC Power Light. Is that the one that I was looking at before? I don't think this was the other one. Power Light 2. Let me just have a quick check and get the schematic up. Yeah, I think it is this one. Yeah, it is. Okay, fantastic. Fantastic. Let's open you with... Okay, so I think this is the service manual for the amp that we've got on the bench. No. So if we scroll down to where the SMP is, oh, no, this isn't the right service manual, this is for the other one. So let me just find the right one. Just close some tabs. Not that tab, not that tab. Not that one, not that one, not that, not that. No, 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 no. Okay, it's gone, so we're going to have to search for it on Google again. Delay is back. Mic check 1 2. Okay, so the delay is still back. Okay, so in that case, I'm going to make this camera back to being 1080p, because that obviously doesn't matter. Doesn't make a difference. So available. Audio device, capture input terminal. Delay is more frequent. Okay. We'll try one more time. If the delay comes back again, I'll just switch over. If the delay comes back again, I'll just switch over to the the microphone in the hat. QSC PL2 PL 236 service manual. Can I just not download this rather than having it in the browser? Save link as? Nope, that just saves that. Okay, this apparently, is it the service manual or is it the user manual? That's the user manual! God's sake. Yeah, how about this one? There we go. Oh! Guys, help me find the stairs. Alright, well they're definitely all stairs. Now would you class this bit as a... No, that's not stairs, that's just the surrounding. So did I get that right? No, I didn't quite get it right. What's going on here? There's definitely motorcycles in all of these. And technically a little bit on these two. And this one actually. Ah yes. Human grade results. Right, this is what I was looking for. Okay, so let's start off at the power supply. So me going through this with you guys might help you a little bit if you're less experienced in reading schematics, to be able to read schematics a little easier. So we obviously have a power supply fault, so we're going to start right at the power supply, the mains input terminals, and we're going to follow this and see if we can figure out how it's working. Now, it might look daunting at first. You've got all this crap like, how am I supposed to figure out what any of this is doing? It's quite self-explanatory once you kind of understand the component markings and where the voltage will kind of want to go in this diagram. So we have AC power coming in here on J19 through the fuse. Now these are some inductors, nothing important at all, just like a bit of high frequency noise filtering, etc. And the first important thing we've got here is this little circuit here. What this circuit will do is we've got a relay, which is K1, and we've got a 10 ohm inrush suppressor resistor, which is here, R324. So when the AC comes in, you can see it's going to go both of these ways. It's going to go into the 10 ohm resistor. It's also going to go up here to this test point up here. So let's follow it on the path of least resistance first. We go into this relay, and you can see this relay contact is open. So therefore, that's the end of that line. So let's go back through this 10 ohm resistor. And you can see that, yep, we're going through the 10 ohm resistor, basically bypassing the relay. And we go to the AC switch. So if we turn the AC switch on the amplifier on, then we connect to W7. So the AC is now here. We continue along here to this. Is a full bridge rectifier, but also it goes down here. So we've got a full bridge rectifier, so we know that the AC mains is being directly rectified. And once it's directly rectified, the DC output from this full bridge rectifier becomes Pri high, which is basically like a bulk rail. It's going to be 400 volts, that guys, scary stuff. And the negative, or the negative ground reference for this is going to be Pri low. So you've basically got rail voltage for the switch mode power supply and the ground reference for that, Pri low, Pri high, Pri low. Cool, that's nice and easy to understand, and that's what the power supply is using to switch between. But remember, the AC also had a little tap here. Let's follow this and see where this goes. We go all the way down here, and we come to a little rectifier diode, a single rectifier diode, D58. Okay, so that's going to be sort of half wave rectified. So we're going to have sort of DC. We've got a capacitor here as well, C107. Let's just check with the chat to make sure everything's all right. Yep. So we have a little capacitor here. So this is basically going to be some noisy DC essentially on here. Not very well rectified, but that's probably fine, because if you notice here, we step through a couple of resistors here, which are likely quite high value resistors, R321 and 322. And these resistor values will probably be different values depending on whether you have a 240 volts or a 120 volts model. After it's been through these resistors, and we also have a third resistor. You can see after the rectified AC has come through these resistors, it goes firstly off to this LM339, but also it does have a pathway to ground, which is Pri-low, the ground reference for this, through another resistor. So basically what we have here is a voltage divider. So we've got two series resistors here, basically forming one resistor. Then we've got a measurement point, or a point where the voltage is what we intend for it to be for the circuit to work with, and then this little last resistor is pulling it all to ground, giving us the desired voltage based on the income voltage and how much it's pulling it to ground. So we're going to have our voltage here, that is whatever the circuit wants it to be, being fed into a 339, into the non-inverting input of the comparator 339. So if you see a little triangle like this, I don't actually know the shapes by heart, but I know that 339 is a comparator. So basically it's going to be looking at voltage on the non-inverting input and the inverting input, and then depending on their relationship to another, whether one is higher or lower than the other, it'll either output a higher positive voltage or a negative voltage, or a ground, 0 volts on pin 14, which is the output of that. So we have, this looks like a circuit that's detecting whether AC is present. That makes sense? You've got it being pulled from here after the it's being pulled from just before the rectifier here. So this is actually AC. So if AC is present, then we'll get a bit of DC on pin 9. So that's going to be detecting that AC is present, and obviously if it's not present, it's going to shut down the SMP. Now obviously pin 8 is another thing there, but we're going to look at that in a bit. We're going to look at that in a little bit later. Let's continue on with the Pri-high. So Pri-high is here. Pri-high is being fed, which is our high voltage 400 volts, into the collector of the IGBTs for the switch mode power supply. So we just look along here, we've got basically our two IGBTs, and these are going to be switching the 400 volts very, very quickly and feeding that into a transformer, which is going to be T2. So you can see here the emitter of this one here and the collector of this one here in what looks like half bridge, I think is that called half bridge, is going to be feeding this transformer T2 here, and that's going to give us the rail voltages that the output section needs. Now what's driving the IGBTs, if we follow the gates, obviously the IGBTs are driven by the gates, we can see here that we have 10 ohm gate resistors, we have a diode in parallel with the gate resistor to help turn the IGBT off as quickly as possible. That's pretty standard stuff, you see that in Class D amplifiers and all sorts. And what's driving the IGBTs is an IR2110, pretty standard stuff. And the 2110 is being fed with its supply voltage. We have a plus 16 volt rail right here. So that is something being generated, so we can look elsewhere on the schematic to see what's creating the plus 16 volt supply for the 2110, and also look up here, it's generating plus 16 volts for something that the SG3525 uses. And this chip here is creating, you can see it's creating the pulses for the driver for the IGBTs. We have output A and output B going into high in and low in on the driver, so that's pretty cool. That's generating the pulses, and it gets its supply. We got VREF up here as something that it needs in order to start working. We've got plus 16 volts up here, which it needs on VIN, which is going to be like voltage in, VIN. We have VC as well, which is also connected to 16 volts up here. So we've got VIN and VC, both need to be 16 volts from whatever is supplying this. And then we have shutdown, and the shutdown goes all the way over to this circuitry over here, which is starting to kind of look like it forms part of the circuit with the 339 that we saw earlier detecting AC. So, okay, that kind of makes sense. This circuit might be, making sure that everything is present and okay. And if it's not, then it will shut down the 3525. So that's a cool way to read that schematic there and kind of just look over there. Okay, yeah, that kind of makes sense. That's what that circuit probably is doing. And we just have some surrounding circuitry to set the parameters on the 3525 that we need for the frequency that we want and the dead time and all that kind of stuff. So that's cool. We basically have worked out how the power supply is turning mains voltage into rail voltage for the amplifier to use at the transformer using the IGBTs here. So let's now, if the amplifier has no power, that's the problem we've got. We plug it in, turn the switch on, nothing, no life, no lights, no nothing. So we're kind of scratching our head thinking, okay, so what's going to be the problem? If we check all the fuses are intact, and if they are, then there's going to be a few problems here. Either the 3525 isn't oscillating, so it's not creating any pulses for the IGBTs, or the SG3525 isn't being fed with 16 volts, or the 2010 isn't being fed with 16 volts, or it's in shutdown. So the next most obvious thing to check would be see what is generating 16 volts for the 3525. We also need VREF as well to be present, so we want 16 volts and VREF. So let's have a look and see if we can find out where that's all being generated. So we've got, scroll down a little bit, you can see we've got a VREF here. Now, is that like telling you that that's creating VREF, or is that VREF being an input? Let's have a quick look. What is this little circuit here? We have VREF as a supply voltage to this little circuit, Pri-low as a ground reference for this little circuit. We have an LM556, which is a, what is that? That's a timer. Okay, so this is a timer. So it's not a circuit that's responsible for creating any voltages necessarily. In order to create, if this circuit was creating VREF, then we would need to have some other input voltage to this circuit that it would use to then create VREF from. So if we look at the lines for this circuit, do we have something that goes up here? We have a little line up here that goes into the sync pin of 3525. So no, this isn't creating VREF. This is using VREF to create some kind of clock signal pulses that then the 3525 uses as sync. So that's not what we're looking for. Let's continue on by scrolling a little bit left here. What do we have here? This right here is the transformer. So you can see here that was showing us that the transformer's here, but then this is a more detailed view of the transformer and all of its primaries and secondaries, capacitors, etc. So that's not what we're looking for really here either, because we don't have any switching. We know that we don't have any switching on the IGBTs, so we don't really need to be looking here just yet. You can see here that we've got plus minus 15 volts, which are auxiliary supply voltages, but that's created from the transformer, so that's not something we need to be looking at yet either. So let's continue on scrolling to the left here, and let's have a look at this. We have a 16 volts here, and it's referenced to Pri-low, and we have a capacitor here. So that looks suspiciously like an output. That looks like, hey, this circuit creates 16 volts. So how does this circuit create 16 volts? Remember, to get 16 volts, we're going to need some higher voltage, or possibly a lower voltage if it's a boost converter, but some other voltage present in order to create the 16 volts from it. So let's have a look and find an injection of another voltage that it could use to create 16 volts. Well, up here, we've got a little label that says plus 18 volts. Okay, well, 18 is a little bit higher than 16, so it wouldn't be silly to think that that might be being used to create 16 volts. So let's follow 18 volts and see where that goes. It doesn't look like it's creating 18 volts because we've got diodes that oppose the direction of flow for that. This is a test point here. Now this here is T. This is a transformer. Okay, so basically we've got a different transformer, T1, which is probably a smaller transformer by the looks of things. So 18 volts there looks like it's created by the secondary of T1. Okay, so that's not super helpful to us yet because it doesn't really tell us where 18 volts comes from, but 16 volts seems to be created by 18 volts coming from a smaller transformer. And the reason we know that is if we look at the 18 volts, if we follow that down, Oh no, sorry, 18 volts is, yes, it's either being injected here or the transformer is making it, but we can look at that in a minute. If we follow 18 volts, we go through a series of 4148s. We've got 3 4148s in series here, so that is very, very, very blocking of back current, back voltage to the, it really doesn't want voltage coming back the other way. And we've got a little point in the middle here where we've got 2 diodes facing each other, and then the 16 volts. We've got a Zener diode here, a 10 volt Zener diode, okay. And if we go back through the circuit further, we've got a transistor here, I've got a voltage divider here on the base. Okay, let's keep looking at this. This is interesting. So this is a TOP210. What does that do? I can't remember off the top of my head what that does. TOP210. Let's have a quick look on the internet. TOP210. What are you and what do you do? Offline PWM switch. Huh, okay, that's going to be creating PWM by the looks of things. We have source high voltage return, control and drain. So that's creating some PWM by the looks of things. Yep. Okay, so we've got a little PWM generator. And what's it using for its supply? We have high voltage here, primary high. So that's our 400 volts. Now that sits on T1. Remember we saw T1 up here as well. I'm just going to check the live chat, make sure that this is working. Yeah, this is working. So yeah, we've got T1 up here, and that's the secondary. I'm going to assume this is the secondary, and this is the, yeah, it is P1, P2, S3, S4. So secondary is here, primary is here. So we've got 400 volts sitting on the primary. So this is going to be a step down transformer, stepping down 400 volts here to what looks like 18 volts. And the pulses for this transformer to oscillate are created by this TOP210. So we need primary high on this transformer primary, and then we have the diode, switching diode there, and a voltage divider here. It's not a voltage divider, so I think it's just a couple of resistors in series there. In order to create a supply. What's actually, hang on a minute, what's actually supplying the TOP210? I've not come across this before. Source high voltage return, control and drain. It's not like something I've really seen before. Let's have a look and see if it gives us an example circuit or something. Here we go. Here's an example circuit. DC input, high voltage there. So we go through a Zener diode here, and then another diode opposing it, which is not a Zener. Okay. Into D there, okay. C is on the secondary of the transformer. Negative DC there, going to the source here at the bottom. I wonder whether it kind of gets kick-started by the when this voltage appears at the DC input. The kind of initial inertia through the transformer creates enough voltage on the secondaries that this thing kind of then gets jumped into life, a bit like starting a car. You've got to kind of give it a bit of a kickstart first, and then it self-oscillates. So I wonder whether that's what's going on here. And if that's the case, if we apply that logic to this circuit here, when primary high appears, then we'll get a bit of a kick. And do we have secondary coming here? Yeah, we do. We've got the Zener diode here, 10 volt Zener. So from 18 volts, which obviously isn't created yet, but anyway, if it was created, we go through the 10 volt Zener, through this diode, another 4148, into C. So C needs to be getting, well, probably somewhere around 9-10 volts, and that's going to be once 18 volts is up and running. But yeah, it looks like 18 volts gets up and running from this. So yeah, it does. It kind of kickstarts itself by the looks of it. So that is where all that comes from. So if this circuit isn't working, then we're not going to get our 16 volts, which means we're not going to get our supply to the 3525 up here, or to the 2010, or sorry, to the 2110 or anything like that. So this is a circuit that I'm going to want to investigate first. I want to make sure that we have 400 volts coming onto the primary of that small little transformer. I want to make sure that we get, oh, what is it? 5 volts it looks like we're supposed to have on here, because it says on the schematic here. 5 volts we're supposed to have on the pin 4 here, due to this resistor. Yeah, we've got a voltage divider here, so that's fine. Okay, cool. So that's what I'll be looking at first. Just a quick overview of the rest of the circuit. What's the rest of the circuit doing? This stuff down here looks like might be some protection circuit stuff. We've got PSOL, power supply overload perhaps, voltage V standby. So I'm probably not going to be looking at that yet. We've got DC off, that might be some kind of, yeah, DC shutdown, so that's DC offset protection. So this is like your protection circuitry stuff by the looks of things, and that needs our 16 volts in order to start working. So that's not a circuit that I want to be looking at just yet either, because we don't have power. Now this circuit here, like we mentioned at the start, this detects by the looks of it whether AC is present on the 339. The inverting input of the 339, that is detecting, let's follow that back, that's detecting a couple of resistors here which look like their value depends on whether you've got a 120 or a 240 volt model. That goes up here all the way to primary high. Okay, so this comparator here, this part of the 339 is checking, firstly, have we got AC mains connected, and secondly, do we have bulk voltage available, and one of them will need to be higher than the other to give a true or false signal on pin 14 depending on how the circuit is set up. And then if that is true, if the voltage is correct on pin 14 because the these two are present and correct, AC and V bulk, basically the pri high, then we get a little voltage on pin 14, which is this trace, and that goes along to over here into this transistor, which probably then allows 16 volts to turn on. So yeah, if this circuit here is creating 16 volts, then we have a little transistor here, Q99, that when we have the unless we have AC mains and primary high present and at the correct values, this transistor won't be on, or maybe it will be on. Maybe it's like, maybe it, no, it won't be on. It will turn it off. Yeah, it must be turning it off until that's present, and then once it is present, we'll get the 16 volts. So that was my little overview of what I can see is going on here. VREF is another one that we saw was required by the SG3525, and actually, you know what? VREF is actually created by the 3525. So that's where VREF is created. It's created at the 3525. So VREF is only going to be present when the 3525 gets its 16 volts. And the VREF is used by one of the circuits over here, which I've now lost. Where is it? Somewhere over here, VREF was used. But yeah, there it is. So yeah, VREF being present here confirms the 3525 is operational. So if VREF isn't present, then this comparator won't be satisfied, and therefore it will probably turn off something else, the protection stuff down here. So that was kind of long, but that's what I have read into this this schematic here. So let me just read some live chat real quick, see if I got any of that right. But that's what it looks like it's doing, and that's what we're gonna investigate, that circuit that generates 16 volts. Let's have a look. I repaired a couple of the QSC, which share the same design. Looking at the complete service manual is really helpful because every part of the circuit is described thoroughly. Yeah, absolutely. Oh, is it now? Okay, I'll have a look at the rest of the service manual. Power issues start with checking the fuse. All done. They're all fine. They also tell us to troubleshoot the amp. Oh, nice. Okay, I'll have a look at that. I just skipped straight to the schematic, not gonna lie. Got loads, finally catching alive. How's it going, my man? Good to see you. The 556 generates the turn on delay so that the bias power supply is on before the main power supply starts switching. The 556. Okay. Where was the 556 again? Oh, the 556 was right over at the end, wasn't it? Got you. Yeah, that would make sense. Okay, cool. Blah, blah, blah. If the amp is completely dead, the circuit for the bias voltage TOP210 is probably defective. Yes, that's the one that I was suspicious of just now looking at the schematic. If the bias power supply is working, the power LEDs light up dimmed. That's really good info. Thank you very much, Electrical. We can check that. We can plug it in and we can see if we get any dim LEDs. If we don't, then probably going to be looking to change some components around that circuit. Right, apologies for the microphone delay. It's an ongoing issue. What I'm going to do is change the source of the audio. Mic check 1 2. Mic check 1 2. That's too loud. Sorry. That was way too loud. Sorry about that, guys. Switching between the mics, one was louder than the other. So that should let me know, how does this look? I've changed it to a different microphone. Let me know how that sounds. Is it synchronized with my mouth? Okay, or is it a little bit delayed one way or the other? Yeah, sorry about that. Sorry about that. The jump scare, the mic jump scare. Sorry about that. It's like in plus 16 dBs because the Osmo mic is very quiet, so it needs a boost, but the StreamCam mic is very loud, so it needs a cut. Alright, I'll stick with this one then. Guys, make sure to let me know if it goes delayed again. Anyway, I was wondering if you'd experiment with passive radiator sometime in the future. I have. If you check my TikTok, I have done a video where I made use of a prefab box and a blown edge 12-inch subwoofer, and I made a fantastic sounding passive radiator subwoofer with the active driver being a 6-inch digital designs from my workshop sub, which I currently use and sounds bloody amazing. But if you're not on TikTok, I don't blame you, because it is absolutely horrendous. I wouldn't recommend you join it if you're not already on there. But if you are already on there, and if you are a TikTok degenerate already, then you might as well check out my Bearvidge channel on there, because there's some decent content on there. I'm probably one of the only channels on TikTok doing decent content that's not just brain rot, but there you go. Alright, so, like I said, it's synced so far. This mic is a bit more tinny and direct. Oh, I'll tell you why it's tinny. It's because I still have the filters set for... Okay, that should be a bit more full sounding. I still had the filters set for the Osmo. So that should be a bit more full sounding now. Anyway, let's identify those components that we were just looking at on the schematic on the actual amplifier itself. So if we zoom in here, zoom, the first thing I want to, if you're looking at this for the first time, is identify the transformers. We know that the transformers are going to be where the different parts of the circuit are. So here, obviously, we have the main transformer supplying the amplifier with its main power, main rails, and we just want to look for another transformer, probably much smaller, for the auxiliary supply. Looks like we have something down here. So if we zoom into this little transformer right here, you can see that that is where we have our TOP210 IC. Fantastic. And all of the surrounding circuitry that is required for that to function. So we can probe some stuff around there with the multimeter, being very, very careful. So in order to probe this, I'm not going to use my scope because my scope is grounded to the mains, and that can end badly when probing mains power supply stuff. So what I'm going to do is I'm actually going to give you a zoomed in version of my hat cam. Now guys, this is a bit dangerous, but let me know if this starts making you feel unwell, because I'm obviously going to crop in on the hat cam, but that might be a bit wobbly for you. But let me know how this goes, okay? If it's too wobbly and too shaky, let me know and I'll crop back out again. But I just want to crop in a bit just so it's easy to see kind of what I'm looking at right here. So in order to probe stuff with the multimeter, what I'm going to do is take my multimeter tip here that I've soldered a bendable end on, and this is just the poor man's kind of clip, I guess. It's going to take my pliers here, bend around, make a little hook. The poor man's multimeter clip. There we go. And then I'm just going to clip that onto the full bridge rectifier. I'm going to clip it onto the pry low, which is the ground reference, basically, for the main bulk voltage. I'm just going to tighten that a little bit because it's a little loose. There we go. And now we can use the multimeter and we can measure some voltages. So let's just get that turned on to 1000 volt mode. So do we have any voltage in there at the moment? No, good. So let's first of all, well, I guess get some voltage cooking in there, shall we? So in order to get some voltage cooking in there, we just need to turn the mains plug on and let it build 400 volts bulk, which is terrifying. I hate these high voltage stuff, but there we go. So we're just going to probe the pry high, and we should see 400 volts appear on the screen. I'm just going to do one last sanity check, make sure there's nothing like fallen inside here that will cause a big spark when I turn on the mains. Doesn't look like there is. So we're going to probe pry high and we should get 400 volts. And also it's a good idea to wear eye protection when working on stuff that's high voltage like this, because capacitor can go bang and take your eye out. It's never good. So let's have a look. Okay, well, we do have some voltage there, and I heard some kind of crackling sounds, which was a bit scary. That won't have come through on the microphone, but it didn't really build the bulk as quickly as I am used to seeing. So I'm just going to hit the mains again. Interesting. Something is wrong. So basically, when I was looking at this not too long ago, which is like a couple of days ago, I got 400 volts just fine. But now when I turn the mains on, the voltage actually seems to drop, which is very strange. Oh no, you know what it is? You know what it is. I've just realised what's happened, and this is a bit dangerous actually. My little hook there has actually moved. Fuck, you don't want that. My little hook there has actually moved, and it's come off of the negative and it's touched onto the AC, which explains why I was getting incorrect voltage reading there. Let's hook that back onto the negative. How am I going to get you to stay there? You did stay yesterday, or the other day. Okay, let's put you back on there. The reason you're not staying is because I've angled the amplifier slightly downwards to show the camera easier what's being shown here. So that's why it's falling off. Okay, there we go. That's going to stay there just fine. So let's have a look at the voltage again. Let's turn the mains on again. Okay, there we go. We've got 330, which is a little low, but should be enough for the amplifier to come to life. So that's, yeah, we're getting a pry high present. So what we want to do now is start probing around in this circuit down here and identify whether the voltages are getting to where they should go. Now, somebody suggested that the service manual actually does have a really good explanation on how these circuits work. So let's have a look and see if we can find that. Right here, downloaded, I just seem to have the schematic. I don't seem to have like a full service manual that goes along with it. So is there a proper service manual for this. QSC 36 service manual. Nope, that's a marketing promo. This is the PLX series, which is not what we've got here. I don't think there's a service manual as such, just schematics. Ah, yo, H1 Nicholas, how's it going, man? Good to have you here. Got to get some of those gator test clips. I do actually have some crocodile clips here, but they're a bit big for what I'm working on in here. I wouldn't want to put a crocodile clip or an alligator clip on these parts in here. So let's go back to our schematic and let's have a look and see where we should probe first. Zoom back into our switch mode power supply section, which was down here, wasn't it? Okay. So yeah, we want to look at this circuit right here. So we could just guess and we could just blindly replace the TOP210, which might be something we could do. But let's see what we've got on pin 4. We should be getting 5 volts. If you know everything is happy, we should get sort of 5 volts on pin 4, which I assume it is what it needs to start oscillating with. On the D, on the drain, we should get 330 volts, the primary high. So we can check that, and that will tell us if we don't get the 330 volts there, then that means that T1 has a break in the primary wind. So yeah, we'll check that. Pin 8 is going to be nothing, and neither is pin 1. So yeah, basically we're just going to be checking 5 volts to see whether there's 5 volts there and 400 volts on pin 5. So 4 and 5. Okay, let's be very careful. Don't want anything sparking or exploding in my face, please, because that's a lot of voltage very close to where there's a lot of low voltage, isn't it? So pin 1, 2, 3, 4. Pin 4 we should have 5 volts. Okay, power on. Okay, we got 0. Okay, pin 5. Pin 5, we have 0 volts as well, by the looks of things. Yeah, okay, interesting. So pin 5, we should have 330 volts, which we don't. So I wonder whether this TOP210 has failed and gone short and blown open the primary on the transformer, or whether the transformer has just... Well, transformers don't really like fail for no reason, do they? So that's interesting. So what I'm going to have to do now is wait for the high voltage to dissipate from the capacitors here, and then go over with the multimeter in continuity mode and just kind of like check the primary of the transformer, try and see where because we should have direct DC continuity from the primary high voltage to pin 5. Did I get that pin right? I was measuring pin. So this is pin 1 with the indent and the square pad. 2, 3, 4. and then 5 over here. Yeah, there's nothing there at all. Interesting. They did not place a fuse or small resistor in case the 210 blows. Doesn't look like they did, does it? Nothing on the schematic there. Literally just pro high straight away into the transformer. Boom, done. Yeah, not good. So we still have 170 volts in pro high. So let's just let that sink down a little bit, shall we? Your probe will disintegrate pretty quick if you short it. Yeah, that's why I don't want to happen. They sell magic smoke on Temu. That's a good one, bro. Oh, time for an ad. Well, I actually have for this stream only. Actually, I think I had it last stream as well. I have YouTube like automatically determining where to put ads for me because I kept forgetting. So if you are using a device and browser that allows ads, you might get one every 24 minutes. I think I've set it to. It just helps me out a little bit. But yeah, let's do some Q&A while we're waiting if you like. Bad switch. Yeah, I did hear some pop. Interesting. QSC are well made. Oh, Calum. They last, well, well made and they last. Ours had lasted a long time and it clips often when using, but works like new. It sits outside an amp rack in the damp. Man, that's pretty cool. Yeah, it looks like a pretty cool, pretty nicely designed and built amplifier. Apart from not having a fuse in line with the this little circuit, but apart from that, yeah, it kind of looks alright. It's it seems to have, if we just take this time to just have a look at the rest of the schematic, we might as well while we're waiting for that capacitor to discharge. So this is the power supply. Let's just actually zoom in at the transformer. I just want to have a look at the main transformer to see what that's up to. So this is the secondary of the main transformer. So it looks like we have a few different rails. We've got high rail, mid rail. So maybe this is like a class H where we've got a step between two different rails that will follow the audio signal, kind of similar to how the Camcos have that I've been working on recently. And yeah, that's just literally another tap, like another secondary here, rectified through the inductor, and Bob's your uncle. So we've got rails of plus minus 134. Yeah, that's not too bad. What are we looking at? About 268 volts worth of rail. It's kind of high, I suppose, actually. Yeah, that's pretty high. These PA amps are designed to drive much higher impedance loads than the car amplifiers that I'm used to working on. So, yeah, much higher voltages inside. And obviously we've got an auxiliary tap here for the plus minus 15 volts for the op amps and whatnot. Let's have a look at the amplifier section, see if we can figure out how that's working. I haven't actually looked at the amp section schematic yet, because I assume everything in here is probably okay. Op amp power supplies, channel A, voltage and current monitoring. Cool. Output section, positive and negative output section. Okay, let's have a look. So we've got our output transistors, 2SA1302. I think that's going to be our outputs on the positive side, and 2SC3281s. We have mid rail coming in here. Where's high rail? Oh, I see. Ah, yeah, there we go. Then we got some MOSFETs. So this is a class H because we have the mid rail being fed to the outputs, but then above a certain output level, we'll get the high rail switched by MOSFETs and applied to the mid rail, but after the diode, so it doesn't feed back to the supply. So that then the rail voltage then increases across the output transistors by the looks of it. I've got an LM311, and what's that being fed with? Neg ref is the input to this circuit, I think, by the looks of it, along with DC. Now DC sense, that'll be for protection. Let's keep going along here. What is this line here? Is that like audio perhaps? Jumpers J5. LED signal display? Oh, okay. That's okay. That's feeding that. Okay, let's go back the other way. Let's go up here to this circuit. Let's look at this. Plus minus 14 volts. Any 5532 coming out of the speaker bus B, coming out of the negative, inverting input there. Further back a little bit is the gain. So I'm wondering whether we have a sine wave here on the coming in here on the inverting input to the NE5532, which then kind of goes off down to the negative step driver. So I wonder whether it's using the sine wave to step up when it reaches a certain threshold, to step up the rails from low to high. Interesting. Right, let's have a look. That bulk supply, that rail voltage should have dissipated now enough for us to probe around. Let's have a look, or maybe we can just go across. We've got 16 volts still on there. Okay, let's just short out the rest of that with a couple of resistors. And just for peace of mind, let's just remove the mains plug. Just, it's off anyway, but you never know. Let's just short the rest of that out. Excellent stuff. Yeah, great. Okay. So, let's first of all check to see whether we have any low resistance between the pin 5, which is supposed to be the high voltage input after it's been through the primary, and this ground here. Okay, no. Well, we've got a reading in diode mode. Let's flip the probes the other way around. No reading that way. Oh, wait, we have the same reading. Let's go and switch the multimeter to resistance mode. Let's go to 200k. What's the resistance of that? 6.5k? 6.2k. So we've got 6.2 kilo ohms between the pry high. It's kind of wandering a little bit, and pin 5. And we'll have a look on the schematic and see whether there is a resistor anywhere in the circuit that would give us this reading, because that's kind of interesting. But we should have a direct continuity between this pin right here, which is the pry high coming out of the full bridge rectifier, and here, which we don't on the chip. It's all very dark. I wonder if can I light, like, the reason it's dark actually is because the camera is looking at this yeah, you can see the camera's looking at this and like it's like, oh hey, this is kind of bright, so it's dimming down the rest of the image. Kind of annoying. Right, can we get to the primary of the transformer from the top of the board here? I don't think we can. Unless I kind of slip my probe maybe underneath there somehow. Oh wait, we've got a little something there. There we go. Okay, so we have continuity from pry high to the transformer, one of the legs in here at least somewhere. I'm actually just going to bend this out a little further. There we go. I'm going to bend this out a little further so I can get right on underneath that transformer there. Okay. So we have continuity to one of the legs. We need continuity to two of the legs because obviously it's a primary, so it's just yeah, we don't. One, and that's it. This transformer has 1, 2, 3. This transformer has 4 pins. And we only have continuity to pry high on one of them. So that must mean that there's a break in the primary wind of the transformer. That's not what we want to see. That's a little more complicated repair than just changing out a part. Well, we might be tasking ourselves with a transformer rewind then, gents. Hot damn. Well, let's just confirm. So the primary continuity to the high voltages on this pin. If I now probe pin 5, which is supposed to be the other side of that primary, do I get continuity on any of these other pins? Which I should do. Yes, I do. Yep, pin 5 has continuity to this first pin, this top one here. I hope you can see that. This top pin here, maybe if I change camera, is this camera better? Nope, that camera's even worse. This top pin here has continuity to pin 5. And this second pin along has continuity to the high voltage bulk. Flipping hell, bro! That's a pain in the ass. Delay? Are you joking me? Mic delay? Huh. So that, if you guys were still getting mic delay, then that must mean that it's the camera's image that's getting delayed and not the audio. Must be. Is there still delay? Yo, what's going on, Jerry? How's it going, man? Good to see you, bro. Big mic delay when switching the cam. Is it when I switch to this one, perhaps? So is it this one that I'm getting a delay on, but this one not? Seems random. Super weird. Don't know what it could be. Well, I think rather than trying to fix it, what I would probably just do is just I need to rebuild this workshop PC anyway. So, but that's not something that I can just easily do in, like, you know, tomorrow or something, because I've got far too much work to do. I need to order some parts. But yeah, I guess I need a more powerful PC in here. Finally did a T-line sub box. Performed fine, except I made it from PVC pipes. Lots of resonance. Yeah. You can, I mean, the PVC pipe is very, very strong, like laterally, is that the right word? You shouldn't really be getting any like, yes, the reason you'll be getting like harmonics and stuff is because of the echoey nature, the kind of material and the stuff. If you stuff the T-line with like stuffing material, it should sort that out. T-lines generally are supposed to be stuffed anyway, I believe. Yeah, Nicholas says check if that is shorted. So we actually checked only a couple of pins. We didn't check all of them. We checked across pin 5 and pin 8, I think it was, and there wasn't a short there. There was just a high resistance. But the high resistance might be there because it did short, but then it was instantly shorted and killed and went high resistance because of the inrush of current. So yeah, there's no continuity, direct continuity to any of the other pins, but that doesn't mean that it isn't toast. So I think on this amplifier, what I'll be doing is I'll be replacing this TOP 210 and making a repair to the transformer, I guess. But I don't think I really fancy doing that right now. That's going to be a task for like, that's going to be like a day of work. That's quite a lot of work, that is. It's going to be like, it's not a lot of work in that sense. It's not like rebuilding the whole output section, but it's obviously stripping the whole board out of the heatsink, which is much more time consuming in a PA amplifier compared to a car amplifier. Obviously changing that chip is easy, but doing the transformer rewind, that's a little bit more in depth. So that's going to be a little more pricey, this repair. Or just a big ass 5-volt supplemental power supply. So like, let's just say, for example, guys, we couldn't fix the transformer. Let's just say that we were completely incapable of fixing the transformer. I'm sure we are capable, obviously, but if we couldn't fix the transformer, could we replace that kind of circuit with something else that will generate 5 volts for that? Well, actually no, because no, we don't need to generate 5 volts because we're not switching the transformer. What we need to do is this circuit. Where's it gone? I've lost the circuit. Where is it? Is it here? Is it here? It is. So this circuit is just taking primary high and it's using that to create 18 volts. That's literally it. So if we were to install some other circuitry that takes primary high, like a buck converter, for example, or something like that, takes primary high and creates 18 volts, and just tack that in place in and around the rest of the circuit, would that even be acceptable? Where's this? Where's this going? We have... Where does this go? This is the... Is that the emitter? Q99? Going... Oh, this is here. This is going to be about 10 volts, probably. Because we have the 18 volts coming through the 4148. So we have a 10 volt Zener. And then just before this voltage divider, stepping it down to 5 volts, we have this connection here, which goes through D69 and goes down to this 339, and this is going to be... Oh, hey, this is an output. Is that an output? That's the output of the 339. Pin 1 and 13. Hello, what's going on here? We have an inductor, L6 2. That needs 16 volts present in order to work. So is that going to be checking that everything's up and running, maybe? This 339 is going to be responsible for... I can see it's outputting. It's outputting to this circuit. So maybe once plus 16 volts is up and running, the 210 is fed with voltage from not only the plus 18 volts, but also... Nah, you wouldn't have the output of a 339 feeding the 210. So yeah, I'm not experienced enough in electronics to understand what that is or what's going on there. It also goes up here. We've also got this here, which is another 4148 going into. No, unless that's a neg. No, yeah, no. Yep, no, not knowledgeable enough to understand what that's doing. Q99 is bypass the Zener diode. It puts the TOP 210 off. Oh, okay, hang on a minute. Let's have a look at that again. Q99 is a bypass for the Zener. Oh yes, so it is. Okay. Yeah, oh yeah, it does, yeah, switches it off. So once that's off, when would you want to switch that off? I guess if you were powering the amplifier down, perhaps. So it's kind of like a safe way to turn the amplifier off. So if this transistor Q99 bypasses the Zener, that will happen when this circuit is activated, which is if there was a fault protection mode. Okay, understandable. Makes a bit more sense now. Thank you very much, Nicholas, as always. It sees a higher voltage on the feedback, so it shuts it off. Okay, cool. Cool. Right, so yeah, this thing needs pulling apart and needs the transformer removing and inspecting, etc, etc. Not something that we're going to do just now. Right. Save that for a day when I've got 3 or 4 hours ahead of me. Okay, so what we can look at next, I'll leave this up to you. We've got a Ground Zero 4K mono car amplifier that we can look at. Looks like it needs a full rebuild, so that might be kind of interesting. We've got a base phase DB 1.4, which is generic Chinese 2000 watts RMS monoblock car amplifier. Again, think that needs a full rebuild, so we can look at that. I've got some parts, actually. I received some parts for the Camco amplifiers. Do you remember, if you were with me when we looked at those amplifiers last time, we discovered that the LM211s were likely the culprit for the issues we were experiencing with the Class H rail switching. So I've got my LM211s now in stock, so we could fit those to the Camco and see if that fixes those. That would be kind of satisfying, because that would be like the end of those, the issues on that one at least anyway. Or I can start looking at something new. I've got another big PA amplifier down here actually. It is a, what are you? You are a EVP 3000 RL. EVP 3000 RL, what's that? EVP 3000 RL. Electro Voice, maybe? Yep, that looks about right. I've got one of these. that also is faulty. No idea what the problem is. Guy doesn't even know what the problem is. What's that? 2 times 1300 watts into 4 ohms. 2 times 1800 watts into 2 ohms. Wow, hey, that's pretty chunky. That's a pretty big amp. So that would be 1 times 3600 into 4 ohms. Wow. I mean, it's not big by today's standards, but like, yeah, I would be like, hey, damn, that's more powerful than my Macrotex. It doesn't give you a mono power rating, I don't think, because it's a proper PA amp. Oh, here we go. Maximum bridged output 4 ohms, 3600 watts. Yeah, and wow, 2600 watts into 8 ohms. Sheesh. Class AB, nice and simple. That's a lot of power for a straight Class AB. Delay. I wonder if I can make there be less delay by sandbagging this camera even further. What else have we got? We've got... Ah, see, 720 is the lowest it goes. That's 1080. Oh, that's TikTok mode. I don't want that. We're going to go 20. Okay, I've switched that to 25 FPS in the hope that that's even less bandwidth. So let me know if that goes delayed again. Yeah, what do you guys want to see? Camco Finale, Electro Voice. What do you guys want to see? Car amp stuff, Electro Voice, or Camcos? You want to see the Electro Voice? Oh, I do also have the T-amp. Yes, we could do a repair on the T-amp, but the T-amp is currently underneath a stack of 4 other amps. So I don't want to get the T-amp out right now because it'll just be a bit of a pain in the ass. Alright, well, alright. I'm going to have to make a poll because I can't keep up. Alright, go. Go, go, go. I've got the Taramps 1500, I think it is. Are the Crown Macrotex broke? Nope, they are my Crown Macrotex I've had for years. They are A-OK. Absolutely fine. I could probably give them a service, actually. You know what it is? I've always been, like, when I got the Crowns, I was terrified of the internals of those, and this was before I did amp repair or anything, knew anything about circuits. So I was terrified of the circuit of the internals. And even though now I repair much bigger amps than those Crown Macrotex, because I was initially scared of the internals before, that being scared of them has stayed with me. Even though, like, to me now it's like whatever, you know, it's just another amp. But it still scares me because I was scared before. So I probably just need to crack one open and have a look. Would you sell those Crown amps? Yeah, maybe. Like, I don't really have a use for them. I only keep them for sentimental value, really, and also doing silly excursion videos, free air stuff and whatever. Yeah, I don't super have a use for them. So yeah, I'll maybe sell them. But they are useful to have kicking around. Just, you never know when you're going to need some decent big Class AB power. Oh, it's pretty strong on the EV3K. EV3K is winning by a fair bit. I'll let the last of you drop your vote in. If you haven't voted, drop a vote. We've only got 23 votes. There is currently probably about 82 people watching, so I know not all of you can vote because you might be watching on TV or something, but let me know what you want to see next, because at the end of the day, this is all for you anyway. I have two Macrotech 500s. Is that meant to be 5,000s possibly? Two 2400s and one 1600. Oh yeah, 5,000. Yeah, those 5Ks are chunky, bro. Nice. That's all I run is crown amps on my DJ set. Good choice. Yeah, it's going to be the EV3K. Alright guys, let's crack this bad boy open and see what we got going on inside, shall we? Right, well then, let's make some space. Some of you guys will recognise this. That's the old realistic. That actually needs a repair. It still works fine, but the clip LED is on all the time. But it doesn't actually affect the circuit. It's just the clip. It's actually the clip circuit that's the problem. All right, come here, you. You are very, very heavy. You are. Bloody hell. I suspect this is a linear power supply, which I actually kind of hope it is a linear power supply, because that would be a lot easier than trying to repair a switch mode power supply. Fucking hell. Oh, I forgot that this is zoomed in. Let's just yes. What do you think about the new Warhorse kicker amps? I haven't seen them yet. I actually need to reach out and see whether Kicker will send one to me. They might actually do that, because yeah, I feel like Kicker are kind of cool guys. I feel like maybe they'd send me one to look at, because Lord knows I ain't buying one. More delay. I think it's the camera. It's nothing to do with the microphone that I select, it's the camera, so. What I'm going to do, sorry, that was a bit clipped. What I'm going to do is switch back to the Osmo microphone, because I think it sounds a lot better. I'm going to turn on the equalizer. Yeah, switch back to the Osmo mic, because I do think it does sound better. And we'll just have to put up with the delay, and I'll just have to keep resetting it every now and then. Until I can get my PC upgraded. Okay, let's get this Chungus on the bench. My boy! Actually, I'm going to leave it on my lap just while I unscrew the main screws. You Phillips? Yes. Sean's like, I ain't buying no Kicker Warhorse either. Man spits facts, bro. Now, one thing that I hope is that this hasn't been worked on before. Hello, Steve. How's it going? Thanks for jumping on, bro. After we've looked at this one, yes, we can do the Camcos. I don't know, because I have no idea what the problem with this amp is, but if this amp is one that needs like fully stripping down or whatever, has the LTT screwdriver been a good investment? Well, I can't really answer that, because I was very fortunate enough to have someone from the States sent this to me They loved the channel and they thought that I could do with a decent screwdriver, so it just arrived one day. So I can't say whether it was a good investment, but it's been a fantastic gift. I'll say that. Yes, it's fantastic. Whether I would also get the same feeling about a cheaper but very similar ratcheting screwdriver, probably, because I've never had a ratcheting screwdriver before. So I think I'm just benefiting from having a ratcheting screwdriver, period. But yes, it's a very nice device. I run my T-Amp E4 250 bridge with 2 ohms. So the one that I've got here failed because it was being run, I think it was being run actually within spec. And it overheated and failed. So I think that you're going to be definitely relying on some impedance rise there. How long would be shipped to the United States? What for, Sean? There's quite a lot of screws in this beast. Oh, like amps from where you're at. So I'm not going to ship any amps overseas. And I don't take work from overseas either. I definitely do rely on impedance rise, yeah, absolutely. My woofers have absolutely crazy impedance rise, but I've clamped about 1400 to 1600. Wow, nice, that's pretty awesome. It blows the circuit breaker after 20 to 30 seconds, no wonder. How's it going, Steve? I'm late to the party. What are you working on? Well, right now we're working on an Electro Voice 3000. Pretty beefy thing, 3600 watts into, what was it, 4 ohm bridged. Sedun, how's it going, buddy? How's it going, Draco? What about from Sweden? No. I don't take work from overseas because the shipping costs are too much generally for it to be worth it for the clients anyway, so I don't want to put them through that. Typically there's always going to be somebody competent in your country already that can service your amps for you. You don't need to firstly pay the crazy shipping to the UK. Secondly, you don't need to risk the shipping to the UK on a boat. Damage from many handlers and stuff like that. There are lots of people. I don't think Bro realizes how big the USA is. The USA is a freaking chungus of a place. It's like a whole freaking continent. It's like Europe. The USA is like the same as Europe in terms of, like, you know. I see each state in America as like its own individual country pretty much. It's freaking massive. There are so many talented people in the States, way more talented than me, that can fix your stuff. You don't got, the only reason that you want to send it to me is because I'm the one that you know about, because I'm the one that creates content. But there will be literally hundreds, if not thousands, of very, very competent technicians that are much more experienced and knowledgeable than me. How are the EV amps? I have no idea. This is my first time seeing an EV amp. Never seen one in my life. So we're about to crack the top open and get a glance at what makes this tick. Hello Team FI, how's it going? Yeah, I'm good, thank you very much. Yo, we're back. We're back. Yeah, I don't know what happened there. OBS just said no. It said that 0 kbps, and then you guys all started complaining. So I didn't lose internet. I think OBS just kind of had a bit of a weird glitch. Okay, here we go. We are in. Some random guy from the street says, like I said, every time I come to his stream, something happens. No, see, what you don't understand is that something happens like this every stream. So it happens on the ones that you come to because it happens every time, bro. Don't worry. Something about someone sent something to someone for two grand or something. Left the amp. It cost me $2,000. What amp was that? And what needed doing? $2,000 is ridiculous. At least there's a service manual for the EV. Nice. I'd love to see it. And sound, yeah. The issue is that for 1K very, very skilled people, there are at least 10K people that are just ripping you off. Yeah, that is unfortunate. I guess you'd need to kind of get references and stuff in it. Yeah, tricky. Right, what are we saying then, guys? I'm going to take you back to the hat cam. I'm going to zoom out, actually. I'm going to zoom right out so we can have a good look at this together. What's it going to be inside? What's it going to be? Okay. Oh, brother. Wow. This looks like the inside of a very complicated modem or something. Something from the 90s or early 2000s. Wow, okay, so yeah, big honkin' chonkin' linear power supply. Rail caps all day long. And then we have some logic stuff going on as well by the looks of things over here. I haven't even actually looked at the back of this to look at its inputs and outputs actually. What do we have? Oh my god! Oh yes, we do have data and logic. We have an RS-2032 232 interface. We have the CAN bus, parallel, control ports, bloody hell. Wow. Well, I hope that none of that's faulty because I ain't got the stuff to test that. Now this looks like output drive circuitry. I'm spotting a couple of little blue potentiometers, most likely to set the bias. What is that? Oh, that looks like a transformer voltage converter something. 115 volts, 115 volts. 9 volts, 9 volts. Okay, 9 volt power supply converter thing. Okay. Lots of relays. Lots of fans under here. So all of the output transistors are probably going to be deep under here. I suspect this board comes out and then the output transistors are underneath there. Yep, we've got, yeah, look through the back. Fuck, there's all your emitter resistors. This is straight class AB, so loads of emitter resistors. So in order to access all of that, actually it looks like we might have maybe an access panel. We might be able to get to part of that from under there. Okay. So unfortunately, I don't have any idea what's wrong with this. Like the person who sent this to me bought them in faulty condition, so they don't know what the fault is. So either, in order to diagnose this, we've got to probe all of the stuff that could be bad or shorted, like output transistors, or just be brave and plug 240 volts in and see what happens. So, I mean, obviously, from the top of the PCB here, there's no burns or visual damage or anything like that, but we can't really see the amplifier. The amplifier is underneath this. Looks like we do have screws that go along here. We could just pull this out, this board. Now, how does the drive circuit connect to the actual output side underneath? This is probably fans. Maybe there's some headers underneath perhaps, or ribbon cables. We've got ribbon cable goes, that's power supply, networking. Right, that goes down underneath. It could be these. Someone's drawn a red line on that. I wonder whether this is the faulty channel. Don't know. So yeah, I don't know. I don't know whether to start pulling it apart or to put some power into it and see what we're getting. Plug it in. The previous owner most likely has already done it, so I doubt you do any more damage. So this has the mains plug has been chopped off. So that's either happened because the amp wasn't working and they nicked the plug for another amp, or they took it off because to remind themselves, hey, don't plug this in, it goes bang, which is obviously not what you want it to be. I guess I could put a 5 amp fuse in and power it up. I doubt the inrush current is that high that it would blow 5 amp fuse. But if there was a fault, then 5 amps instead of 13 amps should prevent there being as much damage if something was bad in here and it was being further damaged every single time you plugged it in. Let's have a look at some live chat. This is great. I love this, guys, because I'm not experienced in PA amp repair, but I know a lot of you guys are, and so this is really cool. This is like we flip it. We flip the stream. Instead of me chatting stuff about how stuff works, it's you guys giving me a hand, which is a little wicked. Looks like Pentium 3. What computer upgrade you gonna do? So to be honest, the hardware's fine, processor, everything's fine. I think I just need, I have like a million USB devices. It's the USB bus that's getting overloaded. So I think I'm just gonna get a PCIe USB 3.1 extension card, give me a bunch more USB slots in the back. That's probably what I'll do. This, yeah, that's only the top layer, yeah, absolutely. EV amplifier play mid so sweet, says Troy. Auxiliary transformer, yep, okay, 230 to 9. Lagging again. Man, that looks like a nightmare. Yeah, it does, doesn't it? I've realised that if I'm going to start doing these PA amplifier repairs, these are going to be more expensive and potentially better earning for me because they're going to take me much longer than a car amp. Because a car amp is actually all there. You open it up, everything's there, but not in this case. Yeah, okay, we'll plug it in. Everyone wants me to plug it in. We'll put a mains plug on it and we'll plug it in. By the looks of that circuit, it might just have a voice. Man, this has got ChatGPT 5 loaded up in it. It's going to tell me what's wrong. It's going to boot up and be like, yo, Bevis, what's up, my man? So basically, my bias supply is dead on one channel, or something like that. I do need a lamp limiter. Yes, Steve. One thing that I haven't got yet, I need to just buy a filament lamp. I do have spare bulbs, but they're all freaking LEDs now, aren't they? I don't have a filament bulb laying around because no one has those anymore. Alfred said, "Look like a modem." It kind of does. It looks like an old game console or some old like freaking PC circuitry or something. I don't know. Judging by the caps, it'll have a pretty high inrush. Well, I'm hoping it'll have this similar thing like what the QSC had, where it has a inline resistor until the rails are built, and then a relay switches over. All right, let's hook up a plug. And let's see what's cooking, shall we? Right, so the brown one goes in the top here. I'm joking. I'm joking, guys. Somebody will take me seriously. Right, let's do this not over the amp, because I don't want any wire strands falling down inside there. That would not be good. Let's pull back a little bit. Incandescents are forbidden to be sold where I'm at. Yeah, I think there's a similar problem in the UK. I don't think you can buy filament bulbs anymore like that. So I don't even know where I'd get one from. Looks like a server. Yeah, exactly. Someone starts screen recording. Bro, there's no need for that. This is YouTube. It's all kept. It's all kept. Do you have an audio transformer? No, I don't. Or do the high rail voltage car amp trick. Oh, that's a good idea. So because this amplifier has a linear power supply, I could just inject my own rail voltage into the output of the transformer. But that obviously wouldn't get this up and running. So I'll have to inject rail voltage, 9 volts, and whatever else this wants. There might be some more secondary taps as well. More secondary winds for like auxiliary voltages. But we could do some basic tests with the multimeter first to make sure that there's no shorts across the rails, or anything like that would be good. One, two, three. Actually, I discovered something interesting about my Macrotechs. Just talking about PA amps in general. So basically, I found out that with my Macrotech amplifiers, my crowns, if you have them powered up and then you turn them off and unplug them from the mains, for a brief period of time after you've unplugged them, you can actually get an electric shock off of the mains plug. Like, there's still some voltage that makes its way somehow onto the pins of the plug. I got a bit of a shock. I was like, "Wow, what the fuck?" All right, let's get let's use a 5 amp fuse just to start with. This is what I was using for the QSC. Okay, and then get the top for this. Top for this plug, which should be over here somewhere. Right, let's put you on the bench because you're hurting my knees. I'm not very strong these days, guys. I'm a bit of a noodle. So if you see me struggling with this amp, then that's why. There we go. Okay. Oh, there it is, on the floor. So I actually agree with Nicholas. This transformer doesn't look like the sort of size that I would really expect for 3.8 kilowatts worth of output. Unless there's another one. Hang on a minute. There's another one! Guys, there's two of them. Let me zoom out. So guys, one transformer, there's another one underneath this board. There's two of them. So 1.5k, that sounds about right, per channel. Okay, so we have our UK mains plug fitted. So let's spin this around. I guess we'll just power it up and see what bloody hell it does. Not looking forward to this. We'll check just check the fuses first and all that jazz. Wouldn't it be nice if this was a simple fix and not having to dismantle the whole thing? That would be lovely. That would be absolutely lovely. So power button on the front. Okay, that's off. Just check that first. Multimeter. Let's check a few bits. Okay, F1 and F2. Some fuses. Okay. Don't know, can I get to the other side of it? Ah, here we go. These fuses are canisters, like little canistry jobby things. So let's have a look at these. Get some tweezers. Okay. What are we saying about these fuses? They look intact. Doesn't mean that they are, but they look intact. It's a good sign. Okay. It's a good sign. Okay. Any more fuses? One here. It's okay. So I mean, it's unlikely that this is drawing high current from the mains, because if it was, those fuses would be popped, I assume. So, is there anywhere else I can just quickly check for shorts to ground or anything like that? That is charging. Now that's charging quite slowly, so I feel like that could be across the rails. That's quite a high capacitance, that the rate that's charging and discharging on the multimeter. So possibly no shorts on the rails. Here we have our full bridge rectifier, or one of them. There's probably a couple of these. There's our full bridge rectifier. So we should have probably a short across the AC input like that. Yup. We shouldn't have a short across the rail here. Nope. Yeah. So this is rail. So we know that we don't have a short on the rail because that's charging. So let's just check we don't have a short between any of the AC lines. No. Okay, that's fine. So that's okay. Okay, I'm feeling a little bit better about powering this up now. So I guess there's nothing else really we need to check just yet from the top here that we can access. So yeah, let's plug it in and see what the heck happens. There is a troubleshooting manual including troubleshooting steps. You know what's funny? Because I've got so used to there not being service manuals for the stuff I work on, it's just not something that crosses my mind initially. But thank you very much for reminding me, Sudden. Why don't we have a look at the service manual? That would make so much freaking sense, wouldn't it? Alright. This is an EV P3000 RL service manual. I am not a robot. Laughs in ChatGPT. Oh, it's a zip folder. Bloody hell. What the heck? Okay. Let's unzip all of this then. Extract to downloads. Folder. Alright, let's start opening some of these in, shall we? Open with Firefox, please. Okay. So this is just the first file that was in the folder. So this looks like preamp, XLRs and whatnot. No worries. Don't think that's what we want to be looking at just yet. We have, analog inputs, slave out, monitor out, and interfaces. Okay. Let's check this one. Mamma mia! Host analog print. IC21. That's going to be that bloody great big thing on the top of that board that looks like a modem. Right. Let's ignore that. That's not what we're looking for. Hello, is it me you're looking for? What's this one? AD converter? Is that also part of this preamp stuff? Analog connector. Oh, analog to digital converter. AD. Analog digital. So I don't think that's what we need to look at either. Now that looks more amplifier. Look how beautiful that is. Look at the symmetry. Look at the shapes. Okay, so what do we have here? This looks like outputs. 2.2, and then hot out. Yeah, so this is going to be output stuff. So that's fine. Like, we can't check any of this yet because we can't get to it. Oh, is it using TO3 parts? Really? Bloody hell. I suppose it would do, given its age. It's very similar to the Macrotechs in terms of, era, I guess. I have no idea, I'm just guessing. Okay. Open with Firefox. Oh, some 4-bit rectifiers. What's this? Transformer A. Is that what's inside of that little 9-volt job? Circuit diagram. Oh, okay. This is some auxiliary supply voltages. I don't know if I can see that board from the top here. It might be nestled somewhere lower down. I can see a few smaller full bridge rectifiers actually on this board that has the rail caps on it. I can see one more smaller one. So minus 26, plus 26, plus 132, minus 132 from the main one by the looks of it, plus floating, something floating, plus minus floating to power amp, to main PCB to power amp. Then we've also got plus 15 volt supply, negative 15 volts. Okay, I mean, if we power the board up, we can obviously check that all of those things are present, so that's something we can do. I'm hoping that one of these files is going to be some text where it tells us some stuff. That looks like the same thing that I just opened, but different. No, we've got more, it's different. Plus minus, we've got 35, just plus 35 for fans, fan, plus 35, plus minus 132, floating, whoa, what the? Okay. Well, this looks like an output stage, but it's not. So is that going to be like drivers or bias or something? Bunch of paralleled MJE 350s. With full rail on them, perhaps, going in. Maybe this is drivers? MJE 350s. Yeah, I think this is drive circuit. I think that's what I've got on the driver boards here. So I think these must be drivers. Drive circuit schematics here for the channels. This is like a separated little thing. LED circuit, yep. And then there's this, maybe some preamp stuff? Not sure. Buffers before the preamp, maybe? Got another full bridge rec. Here's the 9 volts supply, the little blue thing that we saw on the power supply board. There's a lot of separate supply voltages on this amp. It'd be cool if we're just missing one of them or something. That looks like the same thing again. Yeah, it's the same thing again. I think maybe these are just different revisions. Yeah, there must just be different revisions. Oh, what's this? I don't know what these 1 kilobyte HTML files are, but never mind. Okay, so yeah, in that folder we've just got a bunch of schematics. Now, did some of you guys say that it might be, it might not be, but I'll refresh it anyway. Did you guys say that you found a service manual? That would be cool. Evening 13 BTRX 3, how's it going, my man? It's for the P3000 non-RL. Don't know what the difference is. No, neither do I. Alright, well, either way, I think what we should do is just plug it in and see what the hell it does. Right, safety glasses on then. Camera tilted a bit that way. Safety glasses on. No, the files were only 1 kilobyte, so I don't think they were anything interesting or important. Right, I'm going to turn the power switch on the amp. on so that I can flick it on and off with the mains here, rather than having to come right round to the front of the board. So I'm zoomed out as much as I can be on the main camera here. So I can either give you that cam or I can give you this one. I think this one's probably better, it makes more sense once it focuses. Yes, this is my hand and this is the workbench. Yes. Right, so let's plug this in. And let's hit it with some power, shall we? This is actually kind of terrifying a little bit, not gonna lie. If the stream goes dead, then you know that my breaker has switched off downstairs. Ready? 3, 2, 1. Okay. Ah. Interesting. All the lights came on, and then they all went out. Okay, I'm going to go back on again. 3, 2, 1. Whoa! Big surge and some smoke. Oh dear. Right, big power surge. My lights in my house dimmed for a brief moment there. Big smoke. And yeah. That's what I didn't want to happen. That's why I didn't want to put power to it. Because obviously if you see smoke, that means something more has failed. So when we powered it up just now, the first thing that happened was lights on the front here came on. Everything came on. I think Protect was on. And then everything went off. So I turned the mains back off. And then I heard a relay click when I turned the mains off. So I was like, oh, right, okay, so it is still kind of, you know, on to some extent. So then I turned the mains back on again. And had a massive power surge from the mains. Lights dimmed, and I can't remember if there were any LEDs because I was then panicking a little bit, and I saw a little wisp of smoke coming from around this area here. So I think this one we're going to have to pull everything apart. Yeah. No worries. It definitely smells bad. It smells like bad. This is why I don't like just plugging stuff in and seeing what they do, because then this happens. Because I might have a lot more work ahead of me now, you know? So the smoke seems to come from like here, but you know, I don't think there's actually anything on this board that's failed like smoking. I think it's going to be the boards underneath probably. Since there was some smoke, the blown component should be easy to find. Yeah, I just really hope that it hasn't sent further like power and damage further back into other circuits that were fine. So guys, it is currently 10 past 10 in the evening here. I don't plan on streaming for much longer than a further 20 minutes. I won't be able to take this thing apart in 20 minutes. So I can either start taking it apart if you like, and we just do some Q&A, some chats, whatever. Or I can put this to one side for now, get it dismantled in my own time, and then come back with this on another stream with it fully dismantled for us to look at again. And in the next 20 minutes, I could probably actually solder the LM211s to the Camco and see if that then works. Check with the thermal imager. I might be a bit late for that now. I don't know if there'll be any heat left on it, but I'm not turning it back on again. That's for sure. There's a little bit of heat over here. A little bit of residual heat over here. This is on a... do I feel anything over here? This is on a voltage reg, possibly? Not sure. Nothing else on the top of the board, at least. The inrush current suppressors are a little warm to the touch. Why not do this amp on a dedicated stream? Yeah, that's what I think. Ads have not occurred in a while. Should be every 24 minutes. Right, I'm going to unplug this then, and I think grab one of the Camcos, fit some 211s to that, and see how that works. Let's just pop this down somewhere out of the way. Okay, so the Camco that I want to change the 211s on, I think that's this one right here. Let's have a look. Yep. Ah, BTR, man, thanks for the 20, bro. You're always sponsoring this thing, man. Thank you so much, bro. Cheer up, Sam. You'll get the master soon enough. Yeah, man, absolutely. Yeah, I'm feeling all right, man. I'm feeling fine. It hasn't beaten me because I haven't tried repairing it yet, but I'll just yeah, I'll dismantle it, and I shall dismantle it, and we'll do a dedicated stream on it for sure. Thank you so much for the 20. That is a really big donation, dude. Thank you very much. I always appreciate you jumping on and supporting me like that. There's a newer version of the 2092 that can run straight rectified mains voltage. That's cool. Damn. Right, so this is the Camco Vortex 6. This is a much bigger amplifier. Guys, look up the specifications on the Camco Vortex 6. This is a beast. Okay, so I have myself here some new LM211s, and we've got 8 of them to replace on here. Why not disassemble on the stream and give a full video when you put it back together? Because I've only got about 15 minutes left of this stream, and I won't be able to dismantle it in 15 minutes, so it's kind of pointless. Oops. It helps if I actually turn the temperature up on my gun. I forgot that I guess I'd reset this. That was sitting at 100 degrees Celsius. That's not going to melt any solder, is it? Oh, I mean on dedicated stream. I could do, but I think the stream would probably end up being about 7 hours long. To dismantle that fully and chat to you guys, and do it on stream, it's probably going to be about an hour until it's like in enough pieces to start looking at. But did you already put the red LEDs in? Yes, I did. This has all of the red LEDs like we did on the previous live stream, and one of the red LEDs was still turning on and off, so we were like, right, we know it's not the LED. So then I swapped around the LM211s on the side that was kind of cutting in and out, and it started working reliably. So we know that it must be something to do with the 211s here, either that or something nearby to the 211s that was affected by the heat. Like there's these tiny little 6-pin ICs that I haven't identified. I haven't like ID'd them yet. There's these 1, 2, 3, 4 tiny little 6 pins, and they could also be the culprit, and just the excessive heat kind of temporarily fixed the issue. Or like this one, for example, right next to the this one here. Florida Man, dude, coming in with a 5. Thank you so much, buddy. Thanks for coming back and doing live streams. Much appreciated. Dude, no problem at all. I really enjoy it, and I really enjoy the interaction with you guys. So thank you very much for the 5. I really appreciate that, dude. Now the question is, do I blow these new ones in with the hot air, or do I do the safe method of soldering them in with the iron? Because I know like op amps like 072s and stuff really don't like being overheated with the hot air. Fortunately, these boards have a low thermal mass, so I haven't got to super cook them to get them in. But just wondering for like ultimate reliability or whatever, I'm just wondering whether I should put these in with the iron rather than with the hot air. Did your hot air gun come with that end? No, I bought that tip off of eBay, I think it was. It's like a long, slightly bent nozzle, really useful. This is a Class H rated down to 1 ohm per channel. Yes, it is. It's a beast, this thing. So yeah, I think I'm actually gonna solder these in with the iron just to be mega safe. Rather than the hot air. So I'm flattening down the pads as much as possible. First of all. And then we're going to do a bit of flux on all of these pads. And then we can just start dropping these in. And what we want to do is a little bit of solder on the tip, tin your iron. I'm just tacking one of the pins in at a time to start with to get them all like lined up nicely, and then I'll go over the rest of them. Alright, so now we can go around and tack in the rest of the legs. The iron has seen some action. It certainly has. I don't know what tip I'm up to actually. I don't know. I've bought plenty of new tips for this, but to be honest, considering how often it gets used, I haven't really bought that many new tips for it. And it just works. It's great. This isn't even a very expensive iron. It's quite a cheap make. Okay, I really don't like doing it by hand like that with the iron, because I feel like you never get it quite as tidy as you can with the hot air and stuff, but just where these kind of parts are very sensitive and delicate to being overcooked by the hot air, I would rather be safe than sorry in terms of their, you know, how much heat they're allowed to get given at any point. So like, they're all kind of straight, but you know, it doesn't look anywhere near as tidy as it did from factory, or it could do with hot air. But the only thing that's important is that the parts haven't been cooked, and that they are all soldered in correctly on their pads, etc, etc, etc. Cool, looks good to me. Alright, so we'll give this thing some power, and we hope that the LEDs all come on as they should. And that it was the 211s in the end that were the sort of prime culprit, even though I still stand by the fact that the LEDs definitely were bad, because I measured them out of circuit. And even in circuit with the multimeter, and they were kind of cutting in and out. So I need my little adapter for the mains plug. There we go. And then that goes up there. We need some signal in from our XLR. Okay, yep, let's get that plugged in at the top. Let's get these 211s off the top, just in case they fall in. Thank you DJ Q-Tip for the delay notification. Alright, so that's done, and now I just need something to plug into the speaker on the connectors to then connect my scope up to, so we can have a look at the sine wave, the audio waveform. PA and Car Hi-Fi, how's it going? Been a while since I caught you live. Good to see you there, bud. Hope you're doing well. Okay. Okay, slightly janky setup, but it is what it is. So we go there and there, and we have noise on the scope screen, which is that to be expected. Don't remember. Ah, yes, that's because we don't have the plugged in, of course. Of course. Okay, safety glasses again required. And then powering up this thing, and we're looking for good sine waves and all these LEDs to be lit up as we increase the signal level. So one last sanity check of our work. Haven't moved any resistors off their pads or anything like that. No solder bridges between any of these. It looks okay to me. Okay. Cool, so let's hit with some power and yeah, see what this one's doing. Okay, so we have our LEDs. Uh-oh, that's not what I wanted to see. The clip light is back on one of the channels, which I thought I got rid of before by changing the TL074. That's a shame. Never mind. Now, in terms of sine wave, this is one of the channels, looks good. However, the other channel, not good. Not even getting a little bit of a sine wave. Just getting that. Why is that? What have we... Right, power's going off. So I guess we haven't really found the problem then. Which is sad. So I thought I'd trace back the clip LED to the 074C op amp in the preamp over here. So if I pull this preamp card out, we can have a look at this together. So what I was noticing before when I was diagnosing this was that a channel that had the clip LED constantly on and this really nasty waveform was due to something to do with the biasing circuit down here. So the biasing circuit down here should have equal voltages on all four of these, and on I think it's this pin here and this pin here of this header there should be no DC at all, and we should just have the sine wave. So what I'm going to do is power this up again, and I'm going to check the voltages on these and then see if there's any DC on any of these headers. I can't remember with this amplifier which channel it was that had the clip LED on previously. Yeah, that's really annoying, man. Might have to blow some heat over here, over the circuit, to see what starts working and when we blow some heat over. So I'm just going to turn the power back on. I'm going to just probe some things on the oscilloscope here to do with the bias circuit and just see if I can identify anything. Okay, so bias supply, we've got 14 volts, negative 13.9, 14 volts, negative 13.8, that's fine. So now if I zoom right in, on pins 1 and 3 we should have, so we've got negative 0.3 and negative 1, okay, positive 0.4, positive 1.1. Okay, let's try this one. Wow, now this one, this is the one that's out of whack. This is the problem. I don't know where the problem is. So on this one, we're supposed to have, okay, on pin 1 we're supposed to have positive 1 volt or 1.1, and pin 3 we're supposed to have like 0.4. Okay, however on this channel, this is the one that's the issue, and this is intermittent. This comes and goes. I don't know why. On this channel, on pin 1 we've got 3.5 volts, and on pin 3 we've got 2.8 volts. We've got a similar thing on the negative. Oh, hang on a minute. On the, these are both positive. So we're missing like a negative bias or something. Something negative is missing here. See these outer ones? These are supposed to be negative. So we have negative 14 volts going in on pin 2. Pin 1 is supposed to be pin 1 is supposed to be negative 1. And pin 3 is supposed to be negative 0.3. Whereas this one, negative 14 volts going in the same. However, pin 3 is actually in this case positive 0.2, and pin 1 is positive 1.4. So this is the problem. But the weird thing is that I have actually changed over parts from one side to the other on this amplifier. I believe I've changed over I've swapped over these transistors with each other, and it's not that. Is this the one that I changed the 074s on? Let me just check the 074 batches that I've got here. 074202. Yeah, this is the one that I've changed all the 074Cs and the LEDs and everything. So yeah, I'm at a bit of a loss on this one at the moment until we can go further. But the problem is, obviously, this bias supply, which I think is a bias supply, and it's the negative side. So yeah, this one right here, we've got negative 14 on pin 2, and pin 1 and 3 have positive voltage on them, and they're supposed to have negative voltage on them. So that's the issue. But without a schematic, there is no schematics for these, it's very difficult to kind of, you know, trace back and using the, you know, going over the board with the multimeter and trying to find out where the problem is. But yeah, damn, that's anticlimactic and frustrating. One last thing I'm going to do on the stream before we head is I'm going to try blowing over a little bit of heat over this area on the PCB, just to see whether it changes the behavior of that biasing circuit. So I'm going to turn the hot air temperature right down, because I don't want to actually start desoldering stuff and sending components out of their operational range. I just want to blow a bit of heat over them, maybe like sort of 60 to 80 degrees Celsius, something like that, and just see whether something changes about that that biasing supply there, because yeah, that's definitely not right. So I need to try and do this with like both hands. Hold the probe on. See, if I probe this up here, get that locked in, or this down here. If I probe that down here with one hand, and then with the other hand use the hot air station. Right. Sorry. Right, okay. So, with that powered up, let's take our hot air gun. Plop that on there. And let's start just blowing over some random components and see if anything changes its behavior. Not seeing any changes in behavior yet of any of this voltage. yep, nothing instantly kind of changing or happening there. So yeah, unfortunately going to have to look into that a bit further. Use the multimeter, probe back where those pins of those transistors lead to and lead from. Try and find some, because obviously we've got one channel that works and one channel that doesn't. So the key is in the working channel. Just got to try and trace back and find out what's different about that. What's going on there by C4? C4. Where is C4? Oh, C74, sorry, C74. Not much. This stuff all looks a bit different because I've like these transistors and everything here. I've swapped them from the working channel to the bad channel. So I've swapped them from here to here to here to here to here to here to try and get the issue to move side, and it never has. So yeah. Okay, that channel is definitely working super nice. Let's just check. Yeah, so this one we have DC. So you see on this pin we're supposed to just have a sine wave. If I zoom right in on the scope and show you. On this pin right here. Actually, it doesn't even, we're not even supposed to basically have anything. Nothing is supposed to be on that pin there. But on this pin we have DC and a bunch of this crap. So that tells me that the biasing supply is wrong. But anyway, yeah, we're going to have to pick that up again on another stream because it is my bedtime now. Guys, thanks for sticking with me for this stream. It's an interesting one. I hope you learned something. It's interesting to look at all these new PA amps. Just get a kind of different vibe going for stuff for repairing. This is learning curve stuff, and these Camco amps especially are like mega headaches because there's no service manuals, no schematics, weird surface mount faults. This is like proper headache stuff, and if we can fix these, then that's really great, and that's a great experience and loads of stuff learned. So I hope you had fun, hope you enjoyed it, and I'll be trying to stream again a little bit more this week. Maybe we can look at the Electro Voice and these Camcos a bit more alongside some regular car stuff. So have a great evening, and see you later on in the week.